If you go down to Willow Farm to look for butterflies, gutterflies. Hey folks, I have slowed down making videos. That does not mean I haven't been hard at work. Today I'd like to talk about how to at least specify and maybe contribute new hardware to the nixos-hardware repository. Nixos-hardware repository is a project owned. Oh, I want to do that. Is a project. There we go. This is it. It is. It is. Let's see what they say about it. NixOS profiles to optimize settings for different hardware. So basically, instead of from scratch trying to figure out all your hardware settings in every configuration of NixOS, there are settings in the configuration that have to do with hardware. It says what the GPU is, what the CPU is, very low level stuff. And this is a repository that tries to make that effort of figuring out what to put there for that hardware stuff a shared effort between community members. And there are, like, I have a Lenovo ThinkPad P51. So there's a Lenovo ThinkPad, and there's all kinds of ThinkPads in here. There's no P51 in here, which is part of the reason for this video. But there's a P53, and if we go into P53, we can see that there's some stuff here. A lot of this is factored. The P53 has an Intel CPU. It uses this ACPI call thing. It's a ThinkPad, therefore it includes its parent's default .nix and whatever. So anyway, this is a really nice resource for getting your system up and going without faffing around with having to know all this hardware crap. So today, what I'd like to do is I'd like to take a look at how we can because this thing doesn't have a P51 in it. I also have a P50. I have a P52, so I might do those later. But we're going to talk about P51 today. And because I have one, because I know I've done enough messing around with it to know sort of whether it works or not. I stand a shot at being able to first of all, it's useful to, even if I don't submit this code upstream, it's useful to be able to just specify all the stuff in one place. That's sort of separate from my per machine configuration. But it's also, it would be maximally useful if I was able to come up with a configuration that worked and withstood tests such that the maintainers of the Nixos hardware thing, people that review the pull requests, would be willing to accept the code that I have. I could just use ThinkPad P53. Like right now, these machines are very close. Like I could go into my Nix configuration and I could, even though it's a P51, I could say something like this. I wouldn't need, I would happen not to need the rest of this stuff if I did that. I wouldn't need that either. Well, I'd need something like that, but I would need less stuff. But the thing is, if I do that, then if someone comes along and changes the P53 stuff, in a way that's incompatible with a P51, I won't be very happy. And you know, there's worlds of difference between something being almost the same thing and exactly the same thing. So I've chosen in this configuration so far to just say, hey, I have a ThinkPad. Oh, I know it has this ACPI call thing. I know it has an Intel CPU and it has these graphics settings. And I don't try to use the P53 thing. So what I'd like to be able to do is to specify P51 settings in the same way that they're specified in the nixos-hardware stuff. So I'm going to do it the lazy way first, which is a good way to get started. There's nothing wrong with it. What I could do is I could just go into let's see, projects. I'm going to move to the side. I'm going to move this aside. This was me messing around before. Oops. I could just directly check out the upstream repository. This particular way to check out stuff on GitHub requires that you have a GitHub account and an SSH key setup and stuff. There's another way to check it out through HPS that would work without that, but I'm going to do it this way. So now I have a copy of nixos-hardware, and all the stuff I see in here is over in here now. And what I could do is I could just hardware. Oops, I'm already there. Lenovo. We can see ThinkPad. I could just, kind of make a directory. One and hack. I happen to have a directory already because I've done this before. That represents a reasonable configuration of a P51. So let's see, we're going to P51. I'll do it in here. Let's see. Projects, nixos-hardware, Lenovo, ThinkPad, P51. Okay. So this is what I came up with for the P51. You might notice that it's actually a little more verbose than the one that we saw that was for the P53 over here. Where is it? Where are you? Where'd you go? This is the one that Michael PJ, or maybe, I don't know if he did the whole thing. Got it. Initial P53 hardware configuration 3 years ago by Rumick and Rumick. So Rumick came up with this, well, some variation of this that turned into this. And what he claims about a P53 is we know it has a CPU, an Intel CPU. We know it has a CPI call, which is true. And we know it's a ThinkPad. That's what this means, this little dot/dot. And then this is a workaround for some bug that is present in the fan, I guess it's in the CPU firmware, might be in the CPU itself, that maybe it's a software thing. To be honest with you, it's probably some combination. It's probably some combination where the way that it used to work to turn on thermal throttling changed, and the old service, which was called Thermal D, didn't handle it right, so the fan would run all the time and everything. And so he actually put this in here so that this service called throttld would be active, and that would prevent that from happening. Now, fun fact, story time. In the meantime, I've gone on the Arch Wiki, which is the source of all truth, of course, and I've seen that the bug that we were talking about, I think the bug was claimed to be in this thing called thermald, although it's unclear whether it's a hardware thing or software, whatever. But thermald does the same thing as throttld does, and then the kernel's involved and whatever. So given some revision of the kernel and some revision of thermald, the bug that throttld was created to work around doesn't exist anymore, and thermald is apparently still quote unquote more right than throttld. At least that was my understanding of the conversation in the Arch Wiki about it. So if you notice, I have something similar. I have CPU Intel, but then I have common GPU NVIDIA. Ooh, I don't know about all that. But I do have ACPI call, and it is a ThinkPad. Then I have all this stuff in here about NVIDIA Prime. Ooh, Intel bus ID and NVIDIA bus ID. Change this actually. It's wrong. Mode setting, power man. I'm getting jiggy with it, man. I'm going all the way with hardware. And then I have this OpenGL stuff in here. And then like I said, describing the thermald saga, I'm using thermald instead of throttld. So this configuration is maybe more aggressive than the P53 configuration. And I'm not sure that being this aggressive in shared configuration is correct, but to me it seems rather mild, because as far as I understand, I saw some talk about these PCI bus IDs not always being exactly the same, but I can't imagine they would change between, in the same model. And I have two other models, a P50 and a P52, where the PCI IDs are the same as these. So I think it's safe to say that they're probably going to all be the same, but whatever. We'll see what the powers that be say. I don't know what the fuck mode setting is. I'm not sure why it's in here. Power management, enable, fixes a bug where if the computer goes into suspend, sometimes when you restore from suspend, if it's in NVIDIA graphics mode, some windows will be corrupted. And that's because all of the video RAM doesn't get copied properly and restored properly. And when you put this in there, it does. I don't know, man. That's what it said in the wiki. This is for more or less for things like accelerated video and games like Steam and stuff to work with NVIDIA graphics. There's similar stuff inside of the Intel GPU settings, which, okay, so let's take a look. So we're specifying a CPU, which is Intel, and we are then specifying a GPU, which is NVIDIA. This is a little misleading because this CPU line actually implies a GPU. So if we go into common CPU, we go into Intel, default nix, well, it imports CPU only nix, and then it imports the GPU for Intel. And if you notice, the GPU for Intel has very similar stuff for OpenGL in there. Well, it looks like it might be slightly different. I should probably take a look at that. But it also adds a kernel module for the video, which is useful. And we include, the CPU line in our configuration includes both the CPU code and the GPU code for Intel. Then we also include this NVIDIA stuff, which writes this NVIDIA offload shell script that's useful to run things under the NVIDIA GPU, even though you're booted in offload mode. God, I know way too much about this. Then also will allow you to use NVIDIA X server. Let's configures that system packages thing. Does some. Oh, interesting. Okay. Yeah. Yeah. So maybe it's okay that I'm specifying the bus ID in the specific hardware configuration. Maybe the talk that I saw of not having specific bus IDs was only in general for, quote unquote NVIDIA, NVIDIA's for prime devices. Maybe it's okay to specify that. And then we have something very similar to the code that I put in for Intel, where we have these OpenGL packages. Yeah. So let's go back to our Lenovo thing. Pad P51. I'm sure you were fascinated by all this hardware talk. You are just getting tumescent over this hardware talk. I know I am. So, this may not be necessary in here. I'm not gonna. I've already spent too much time describing the weeds of the specifics about this thing, so I'm not gonna change it because I know this actually works. But that is our stab at specifying what a P51 looks like in hardware. So currently, I have another repository that is called nix-config, my own personal repository, that specifies configuration for a number of machines that I have. This ThinkNix51 is a P51. Let's see. What's in here? It's hardware configuration. Okay. And yeah, that was the thing we saw before, where I specified that it's ThinkPad, does all this stuff, and calls into this Optimus Nix thing. So now that we have this checked out, we can actually get rid of some of this ad hoc configuration here. We can say instead of that stuff, I'm just going to specify it. Just gonna steamroll it by specifying an absolute path to it. Hardware, Lenovo, ThinkPad P51. I can, because I'm doing that, I can get rid of this and this and this and this. Isn't that better? Now let's see what I took out. I took out common Optimus. Okay. Well, we put that stuff in there. This looks suspiciously like what I put into the P51 configuration. And let's see what I have in here. I don't need this anymore. That's done by stuff up top. Okay. Oh, this has got to go. That's got to go. I had problems with that today. So enabling true. Allow on free. TLP. Oh, by the way, because this thing actually, there's more configuration that it actually imports, because it's a PC. So this actually gets imported at some point. And then it's also a laptop, and this gets imported at some point. So TLP gets enabled by default once we include this stuff from the hardware, nixos-hardware repository as a bonus. But we're setting some extra stuff for TLP where we tell it to stop charging our battery at 80%. Okay, thermal D, we can get rid of, because that'll come from the nixos-hardware configuration. Oh, okay, so our configuration is looking a little slimmer. That's good. I eventually can delete this file. It's not going to be in use anymore. This Optimus file. 51. What do we have in there? Hardware configuration. Yeah, the rest of it's right. Okay. I have things set up in such a way that this alias called Swinix will build this configuration for me. So I'll try to build it with all the files that I have inside of my nix config directory. Let's see if it works. Nope. Let's switch file directory. Home. I forgot Chrism. Projects. Oh yeah, man. Okay. Configuration X. Okay, so I forgot to remove something from our. We no longer need to build that ourselves. That'll get built for us. Okay, so if you notice, it didn't actually make any changes to our system, or at least it didn't build any new derivations, which implies it didn't make very many changes. You know why? Because the configuration I'm currently running was made from a configuration that I had built almost exactly the same way, an hour ago. So it's not surprising. So, and as I'm in OBS and as things are running, I'm even in, I think I'm even in sync mode. Yeah, I'm in sync mode. It does work in offload mode too. Everything works as a result of that. If I rebooted and, went into it, it's not detectably different from when I had inlined all that code into my own nix config repo. So good, right? At least we have separation concerns. We have one repository that handles our hardware, and the other one doesn't have to know anything about it, just imports it by virtue of knowing that it is a P51. Okay, so the upsides of this strategy, where we have this code living on our file system somewhere and we can import from it, it's easy to change. We negotiate with no one. Fuck them, man. We're gonna do whatever we want, and it's easy to check in this code to our own repository and just maintain it ourselves if we want to. So the downsides are the mirror image of such a thing. If I do that, I get the benefit. I don't get any benefit of having other people's eyeballs on the code that say, "Hey, look, you have this up here. This isn't going to work in the future," or this isn't general enough to work for other people, or whatever. You might not care about that, but often those sorts of insights, even if it doesn't directly apply to you, can make it better. I can't easily share it between systems without actually checking it into my own repository, which just totally defeats the purpose of having shared NixOS hardware in the first place. So, it's got some nice upsides, got some pretty shitty downsides, whatever. One way we can make things slightly less shitty is, instead of checking out the NixOS maintainers version of the nixos-hardware repository, we can fork the repository on GitHub, and this will make it easier in the future to. I mean, first of all, we can every so often pull patches, pull commits that are made to the upstream repository into our fork. You know, so if somebody fixes some bug in our stuff or in any stuff, we can grab it pretty easily. And the other reason to do this is to be nice. Some combination of nice and selfish, because we can submit a pull request. Often people think of that as a civil act. A lot of times it's a provocation. It's not always very selfish, because we can think of it as we want to help other people with you know, setting up their hardware. But if we disappear and we've given code to people upstream, well, then they have to maintain it forever. Well, maybe not forever, but they have to. So either somebody's got to take it over and maintain it on your behalf, or it's got to be deleted from the repository. So pull requests, merging pull requests is a dicey business that requires negotiation, review, and give and take. And so it can take a little while, but it's worth it in the end. So that's the other thing that's good about it. So forking our repository, forking the repository. So let's do it. Fork. We have forked. Fork it. So now that we've forked the repository, we can, let me go back to here, projects, nixos-hardware, git status. Do I still have P51? Let's see, did I make any changes to it? I did. So but it's not that big a deal. So I'm going to just blow this away. This nixos-hardware repo that we checked out. nixos hardware, and we're going to check out our fork instead of the upstream. Okay, now we have exactly the same thing that was in upstream, except we are in control. We can make commits to it without anybody's permission. We are wearing the big boy pants now. So I'm going to copy CD into nixos-hardware, Lenovo, ThinkPad. I'm going to copy our P51 directory into here. And let me just change that real quick, because I know there's a problem with it. Lenovo, ThinkPad, P51, default. Okay. Okay, fine. So Where was I? I was in my script. All right, now the second, and then this step isn't totally necessary. I prefer to do it. I like to make a branch inside of forks to do work on. Partially because it's easier to delete a branch if you just make a bunch of commits that are just garbage. It's easier for me to remember how to delete a branch than it is to delete a bunch of commits from master. So I just make a branch, and it's also a lot of upstream maintainers like it if you make changes on a branch. That may be more applicable if you're not in a fork already, but whatever, man. Just let's get it over with. Anyway, I'm not gonna justify it anymore. So git checkout B P series additions. Then we'll create a branch. Now we're in our branch on branch P series additions. We can add Lenovo ThinkPad P51. Status okay. And git commit, add initial stab at P51. Yeah. Now we have to push it up, so we have to set our origin as upstream. ThinkPad. Oh, is that what do we call it? P series additions. Okay, now see, oh, it knows. Wow, that is fast. That is really good software. GitHub. So now there's a branch in here, and called P series additions. And now, if I run Swinix, remember that our local configuration, our nix config configuration, is still pointing at home custom projects. So it's pointing at the same place. There should not be any changes. We changed nothing. Well, that's not true. We did change something. I think I changed it from offload, sync to offload, or did I? I forget. Maybe I didn't. Maybe that was just, yeah, I guess I didn't do that. So, yeah. So now we're in the same place we were before, but we have we are our own fork, and we can commit. We can pull changes from upstream if we need to. We can, in theory, submit a pull request upstream, although we're not quite ready to do that. The thing is that we're still in the same spot where we were, where we have these files on disk and no way to share them between machines. I have these files on this P51, but I have another P51 that I'd like to use too. I'd like to have the same configuration for. That's the whole point of my nix-config repository, is to share configuration in a central place. So, you know, I could just take this nixos-hardware thing and you know, like copy it into my nix config. You know, that would be pretty silly. Like that would be pretty silly, because, you know, we have a git submodule or some garbage like that. But neither one of those are a good idea. Nix has a way to let us use. Well, I shouldn't say neither one of those are a good idea. There's some downsides with what I'm about to show you, but yeah, it's both potentially a better way to do it for shared configuration, and it's also a way to learn about how the Nix import system works. So we're gonna do that. Nix has this concept of channels, and currently I have 3 channels configured. I have The reason I put sudo in front of that is because the way I set up my system is to run nixos rebuild, and the only channels considered when I run nixos rebuild, because it's running as root, are these channels. So I have to sudo the list. Hey, my cat just knocked over a hamburger. You can't have that. That's mine. It's mine. It's my hamburger. What we can do is, instead of using a path import here, we can create our own channel. All a channel is basically a tarball that exists that when you unpack it has a certain directory structure to it. And in particular has, I think the only real, I could be totally wrong about this, but I think the only real thing required is that either at the root or in some subdirectory of the root, it has a default.nix in it, and then then it's just code. It's just like it lived on your file system. It will live on your file system after we after we add a channel and update the channel list. So let's do that. Let's go ahead and say add. Okay, so I'm going to change the name of this. It's no longer a branch name. We sudo nix-channel add, and then, although we've been using this where are we? This URL to get at this GitHub URL to get at our repository, our fork. We can also access it through HTTPS. So this is the same, basically the same URL as what we use to clone the thing. It's just different transport method. McDonk, nixos-hardware, and then if we append archive/branch name, which is p-series additions, .targz, and we can call it nixos-hardware fork. Okay, now we've added a channel. We haven't, adding the channel doesn't download anything from the URL. It just makes it available for things to be downloaded from. In order to update the channel, in order to download stuff, we have to update the channel. Update all of it. If we do that, we'll update all of our channels. Okay, so as a result of calling nix-channel update, it's built a derivation which is called nixos-hardware fork. And now we can replace this stuff in here. You could say nixos-hardware fork, like that. And we should get exactly the same outcome as we did before. So now I'm going to do swinix. I think it's going to succeed. Indeed. Yep. No changes were made because no changes were made. It's the same thing. It just happens to live in a channel now instead of on the file system. So that is the difference between path imports that start with that have a slash in them, that don't have these surrounding angle brackets. Paths in Nix are they're not strings. They're not inside of quotes like that. But if you put anything like foobar like that, it tries to resolve it as a path. Anything in these angle brackets is considered a channel import, and yeah, it's specified that way. So, given all that, where are we? So the upside, so code is accessible in a channel, so we don't need to check our code into our own repositories. Well, I mean, it is because we're on a fork, but we don't have to put it in a place where it's not forked from the upstream. And now, if we want to, we can hack and hack and hack and hack, and then eventually we might be able to submit our changes as a pull request upstream. So the downside is that, let's say I make a change to this P series additions branch. Let's say I go into Lenovo ThinkPad P51, edit, configuration.nix, nope, default.nix. And let's say I change this to that, whatever. So that is a big change as far as that would definitely result in new derivations being created if it ran. So let's say git status git commit am switch to sync mode like that, git push. Okay, now that changes up in this P series additions branch, and channel list. We're still pointing at this archive that's generated nicely by GitHub for us if we pointed at this URL. And so you would imagine that nix-channel update would do something, but it does not. If I run Swinix again, if that change was noticed by the system, we would definitely have something being rebuilt. We'd see derivations being built. But I'm running Swinix, and it did nothing. So the way around this is to go into this our fork, and we can go to our P series additions branch. We can actually, we don't even need to do it in the git tag. P series additions v1. Right. And then how do you push tags? I always have to go look this up. Let's see. Push GitHub tag. Okay, I guess it's just git. Wait, did I commit? Yeah. Push u origin P series additions 1 v1. All right. Okay. So now I haven't done this before, so this may fail. I'm pretty sure this is the way it works. Next channel list. Right. Next channel remove. nixos-hardware fork. Then we do add P series additions v1. That becomes our nixos-hardware fork. Now, if I do, I have to do nix-channel update. And now if I do Swinix, okay, that's actually better. I made that change blindly without testing it first. I actually expect that's exactly what should happen. Anyway, that is a dizzying tour of both nixos-hardware and how channel imports work. And hopefully somebody gets some use out of it.